Jai Hind everyone. I am Vaishali Rastogi. Today I am going to take the lecture on process and scheduler under operating system subject. So let's continue with the topic. First, we are going to learn about what are the contents of process definition, process state, context switching, CPU bound versus IO bound processes, process transition diagram, and in last we will learn about what are the schedulers. So let's continue. A process is a program in execution. For example, when we write a program in C or C++ and compile it, the compiler creates binary code. The original code and binary codes are both programs. When we actually run the binary code, it becomes a process. So in short, we can say that process is nothing but is a program in execution. A process is an active entity instead of program, which is considered a passive entity. A single program can create many processes when run multiple times. So this is the basic definition of a simple process. Yeah, else we if we continue in the what now we will continue with the what does the process looks like in memory. So here you can see with the diagram that this is a complete diagram of a process and how it looks like in memory. So first we can see that here we have stack, heap, data and text. We have 4 sections over here. Let's learn about the sections detail. So first we will learn about the text section. Text section is nothing but includes the current activity represented by the value of the program counter. And next we will move towards the stack. The stack contains temporary data such as function parameters, returns address, and local variables. Next we will learn about what is data section. Data section contains the global variable. All the global variables of a process comes under data section. And in last, we will learn about what is heap section. Heap section dynamically allocated memory to a process during its runtime. So this is a basic simple structure of a process when it resides inside the memory. So next we are moving towards the process state. So first we will learn what are the states. States are nothing but a simple step or a process. States are nothing but a simple place where or a condition where a process shows what is the process is doing. Like if I'm teaching right now, that this is my teaching state. You are listening the video or watching the video, then your state is basically a watching state. Okay, so every process has a different kind of state. When we talk about the process in operating system, then we have some specific pre-decided state of a process, which names are new, ready, run, wait, complete, and suspend ready. Last one is suspended block. So let's learn about each of them one by one. First is new. Newly created process or being created process. In this state, all the newly created process and the process which are going to be created comes under the new state. And in ready state, after creation of process moves to ready state, the process is ready for the execution. Means whenever any process has been created and it wants to, it is ready for execution. This state basically a ready state of a process. Third one is a run state. Currently running the process in CPU, only one process at a time can be under execution in a single process. What is the running state? Running state, whenever a process is running in the CPU time. So this current state is basically called the run state. And the fourth state is basically the block or wait. What is waiting? Waiting is something like you are waiting for a train, you are waiting for a bus. That is a status, waiting state of you at station. Whenever a process wants to execute themselves, but due to some situation or condition, they have to wait for the execution. This kind of state of a process is called a wait state. And when it comes to the block state, when the wait becomes more and more. So when a process requests IO access and or when a process is waiting for IO access is basically a process state. So these are the basic 4 state of a process. Now next we will learn about the further state. Fifth state we are having as complete or terminated. The process completed its execution. Whenever the process completes their execution, the state becomes complete state of a process. Or terminated. Terminated is basically that I have a task of creating this video. After creating this video, I will just complete the video, or the completion of video means completion of my task. Basically, I will terminate my complete lecture after completing this video, because my job is done. My job was the creating the video and my job is done. So I will terminate from here because my task has been done. So as the process complete their task, the state becomes a terminated state. But here we are having 2 more states, which are suspended ready and suspended block. We have already learned about what is ready and block state. So first we will think about what is suspended. The suspended terms comes when any kind of waiting or situation, sudden situation occurs in the terms of ready state or block state, then these kind of new 2 state created. So first state is basically the suspended ready. When the ready queue becomes full, some process are moved to suspended ready state, and suspended block when waiting queue becomes full. So these are total 7 states we are having under process state topic. So let's move towards the next point. So next we are going to learn about context switching. The process of saving the context of one process and loading the context of another process is known as context switching. In simple terms, it is like loading and unloading the process from running state to the ready state. We have already learned about the ready state and the running state. So if a process wants to come from the ready state to running state or running state to ready state, then this basically process we can call it context switching. So let's learn more about it. When does context switching happen? Main problems comes when switching is happening. How we will know that this is the context switching? So when a high priority process comes to a ready state, means whenever a higher priority is coming and lower priority is running process. So then in some situation we have to go for the context switching. Another time whenever we are having any kind of interrupt, then we have to apply for the context switching. Or in third condition, whenever preemptive CPU scheduling used. So these are the basic 3 conditions to create the context switching method. Now we are having the next topic is CPU bound versus IO bound processes. So first we will learn about what is CPU bound process. A CPU bound process requires more CPU or spends time in running state. Whereas IO bound processes, an IO bound process requires more IO time and less CPU time. An IO bounded process spends more time in waiting state. Means whenever a process is requiring for CPU, it needs more CPU time. Then it comes under CPU bounded process. And whenever the process is requiring for IO devices, then it comes under IO bound processes. So we have learned about all these kind of processes. Now next we are moving towards process transition diagram. So here I am just going to create the diagram step by step. You can learn from the particular you can draw the diagram with me, and you can also learn it from a simple example. So let's start. First state we were having was a new state. Sir, iska wo pen. So now we are moving towards the process transition diagram. So let's create the diagram first, and also while creating the diagram, we will learn about all the state and how they are working in the terms of process transition. Okay, so first we have 7 state earlier. So first stage was new stage. and another was ready state. And we were having running stage and terminated. Apart from that, we were having a simple basic state. Apart from that, we were having one more stage, that was waiting stage or block. Earlier, we have learned about these 5 basic stages of process, and I have created the steps. Now we will see how these processes are working. So, whenever a process is going to create or created, it comes under new state. Let's suppose we are having a process which is already under in new state. So, it will move towards ready state. Whenever a process is created. Okay. Now, we are having the process under ready state. And it is going to move towards the running, because every process wants to execute their task. Whenever a process wants to execute their task, it have to move towards the running state from the ready state. So it is basically happen due to of dispatch. Okay. Let's suppose if a process is already under in running state, and it already completed their task fully. So it will move towards terminated when it get completed. Now the process has been completed their task in running state. So it is going to move towards the terminated state when the processes get completed. Okay. So a process get created in new state, it get ready in ready state after dispatching from ready to running, and here in running state it is getting executed their task, and after completion of the task it get towards the terminated state. Okay. So now what is the role of wait and block? Whenever a such situation comes that a process which is in running state, and while in running state, it needs a IO device. A process is requiring for IO device, and that particular IO device is busy with another process. In that situation, it goes towards the wait and block when this device is required IO. Okay. And after IO request, whenever a process required IO request, it goes toward the wait and block state. And after requesting approval and getting the IO device under wait state, it get back to ready state, which basically IO completion. Okay. So IO request and IO completion. Okay. So these are the basic structure of a simple process. When it comes, create, ready, running, after execution the task it get completed, or if it needs a IO device, it goes to the towards back, block and wait, and after getting the IO, it goes to ready state. Okay. But in some situation, a priority kind of problem, whenever a lower priority process is under execution and higher priority process comes to running state, then in this situation, the process will go back to ready state. In which situation? The higher priority jobs. Whenever higher priority jobs comes toward the running and already lower priority job is running in the running state, so due to that priority problem, it get back to the ready state, the lower priority problem. Okay. So this is the basic architecture, but here we are also having two more states, which was suspended ready and suspended block. So let's create these. Both two states comes when the problem occurs of memory. Okay, so what was the states? Suspended ready and suspended block, or wait, okay. So now we are having two more states over here. How they will perform their work? Whenever a process which is residing under wait and block, and it is also requiring some more memory, or the current RAM is full, and this situation we need extra memory. For the requirement of extra memory, we need this extra stage, which is basically showing the request of memory. Okay, so this process is basically suspended from current memory and it is going towards the suspended wait. But the process which is already in suspended wait and it is requiring the memory request and it is getting the memory, the RAM basically, so it will go back towards the wait state. It is waiting for the IO device. Okay, this wait and block is basically for the IO device waiting, and this wait block is basically for the memory request. Okay, so here we will just resume the request of memory, and here it is again comes back towards the RAM memory. Okay, but what happens if the process gets the IO devices but still it is requiring for the memory? So whenever this process is requiring for IO devices, it comes over here, and also for the memory, then it goes over here. But here the process, it getting the IO devices but is not having the sufficient memory, then it will go towards the suspended ready. When the process is completed, process having IO completed. Okay, but also requesting for the memory and still it is in suspended situation, then it will go towards the suspended ready. So now if the situation happens that the process which is in suspended ready, it is also requiring for the RAM memory and it is approving their request, then it goes towards the ready state in the terms of resuming. And again, if a process is in ready state and it is also required some more memory, or a ready state is full with the RAM is full completely and it is having more states and it is only requiring some extra memory, at that time the process move towards the suspended ready. Request of or suspended request memory, or it is suspended due to lack of memory or overfull of ready state. In such situation, the complete process of 7-state diagram of transition of process. Okay, so you can have a full look of this particular diagram over here. Whenever you are going to create this diagram, never try to feed it like a complete diagram. Just learn about the state and the situation, what is happening inside and what is happening between the state transition. If you learn these concepts of why this is moving towards from here to here, this story will help you to learn this complete diagram. So this is the complete diagram of process transition. So next we are moving towards the schedulers. Schedulers are basically the monitor which are just maintaining the movement of these process from one state to another state. Okay, so we are having three types of scheduler. What are three types of scheduler? Long-term scheduler, short-term scheduler, and medium-term scheduler. First, we are talking about long-term schedulers. It brings the new process to the ready state, and long-term scheduler, also known as the job scheduler. And last point we are having as long-term scheduler controls the degree of multiprogramming. Okay, so these three basic points for long-term scheduler. Next, we are going towards the short-term scheduler. So short-term schedulers basically is known as CPU scheduler. It selects one of the job from the ready queue and dispatch to the CPU for the execution. The job of short-term scheduler can be very critical in the sense that if it selects jobs where CPU burst time is very high, then all the jobs after that will have to wait in the ready queue for a very long time. Ready queue is basically comes under the ready state. Okay. And last we are having as the medium-term scheduler. So medium-term scheduler takes care of swapped out processes. If the running state processes need some IO time for the completion, then there is a need to change its state from running to waiting. Whenever we are having the situation of changing the process state from running to waiting, in this situation we are requiring for medium-term scheduler. It removes the process from the running state to make room for the other processes. Okay, so this is all. We are having three kind of scheduler. So what we have learned in the particular video, that what is the process, and after that the process states, process transition diagrams, context switching, and last one, the schedulers. Okay. Apart from that, we have also learned about the CPU bound process and IO bound processes. So next we will continue this series in another video. So thank you for this for watching. Thank you.